All right, this is just a quick screencast to show the difference in what we call motion graphs. There are three types of motion graphs. All we're talking about here is just things that are moving. If you were to graph how they were moving, what would it look like? All right, and so the first one I have here is called a position versus time graph. The second one is a velocity versus time. And the third one, which you can't quite see yet, is acceleration versus time. All right, and so what I've done here is I've drawn three possibilities in different colors of what a position versus time graph looks like. When we think of position, we just think of where is the object. All right, if that object has over time a line that's going horizontal like this, it just means that it's at some point, but it's not moving. If you can picture there being numbers here, all right, how far away from some known place. This object is staying on the same number as time goes on. It's staying in the same position. So we call that just being at rest. All right. Two other possibilities. This green line, now this object here is not staying still. It's moving. All right. But if we had numbers such as 1, 2, 3, 4, every second, it's moving the same amount of distance. In 1 second, maybe it moves 1 meter. In 2 seconds, it moves 2 meters. 3 seconds, it moves 3 meters. To the third meter, I apologize, let me back up. In 1 second, it moved 1 meter. In the second, so in that span of one more second, it moved 1 more meter. And so it's continually moving the same amount, and this is moving at what we call a constant velocity. So in a position versus time graph, which you may see using some of the equipment we have here in the classroom, it'll produce a position versus time graph. You need to know that a straight line going up in that direction is an object moving at a constant velocity. And the other option is this curved line. And what we have here is an object that is not moving at a constant velocity. It is moving. And so if it's not constant, it must be accelerating. So we call that acceleration. And that acceleration in this case is positive acceleration. It would go in a different type of curve, a different direction, if it was decelerating. All right? Now these change when we look at velocity versus time graph. A straight line going across does not mean at rest in this case. I'm going to try and adjust the camera over just a little bit. All right. A straight line moving across now means, if you can think of numbers being on here, that now it does have a velocity. It's not on the 0, it's on some number. And so as that moves across, it is staying on the same number. It's staying at a constant velocity. So a straight line in this type of motion graph, a velocity versus time graph, means a constant velocity. Okay, green line here. Well, before it meant constant velocity, not in the case on this type of graph. On this type of graph, it stands for it's increasing its velocity the same amount each time, and we call that constant acceleration. If I dropped a marble from a tall building, gravity would pull it down to the ground at the same amount of acceleration the whole time, 9.8 meters per second squared. That's how hard gravity pulls that object down towards Earth. So that's what a straight slope means on this type of graph. And then this is just a changing acceleration. Okay, so this is a curve is just going to mean a variable acceleration. Okay, and I hope I'm not going too quick, but I just wanted this to be on our website for reference. All right, and then the third one, and I hope that's lined up okay. I'm going to erase that real quick. Here we go. The green line in this case, you'll notice an acceleration versus time graph, and it's on the 0. So we've got something that's not accelerating. It must be moving at a constant velocity. Now there is another option for for this green line, moving at a constant velocity, or If it's not accelerating, it could be at rest. So I'm going to put at rest. All right. This object here has acceleration because it's at some number, it's at some value, and it's staying the same as it goes across. It's my attempt at a straight line. We would say that that object has constant acceleration. And then finally, that red line is a changing acceleration. So I'll just call that variable acceleration. All right, it's changing. So there we go. There's the three types of motion graphs that you're responsible for: position versus time, velocity versus time, acceleration versus time, and what the possible lines would stand for. All right. So that's just a short screencast, and I hope maybe that helps as a reference. Okay, that's it.